All right, so today we're talking about the trig ratios, guys. This is where we get to the heart of trigonometry. Okay, trigonometry is a study of the relationship between the sides of a triangle and its angles, and this is what it's all about. It's what trigonometry is based on. So those are what we call the trig ratios. And if we get some time, we'll also use those to actually solve some right triangles. In other words, that means find some missing sides. That's pretty much it. So to kind of start us off just with a concept, you don't need to write this slide, okay? You do not need to write this slide. I'm going to draw you guys a picture here. I'm going to put a 60 here, and I'm going to put a 5 here and an X here. I'm going to draw this. I'm going to put a 60 here. I'm going to put a 2 here and an X here. All right. So, somebody want to share with me what the X is on that? Let's say the one on the left first. 10. Okay. Why is it 10? That's right. So we double it, right? First of all, you have to notice that since this is a 60, right? This is a 30, 60, 90 right triangle. And we know that the hypotenuse is twice as much as the leg. So this has to be 10. Okay? And so what would the one over here be? It'd be 4, right? Now, this is a ratio. Whenever you're talking about a 30, 60, 90 right triangle, the ratio of the short leg to the hypotenuse, ratio means you can make a fraction out of it, right? The ratio will always be what to what? 1 to 2. It's 1/2, okay? That's a trigonometric ratio. When you take the sides of a right triangle and you make a fraction out of them, it's a trig ratio. Now the reason we were able to get this answer though is because I told you this was 60. If I told you this was 45, that would change our answer, wouldn't it, right? All right. So if you guys have your cell phones, get your cell phones out for me really quick. And open up your calculator. Now, there's 3 sides on a triangle, and you can make all kinds of fractions out of them. And all those fractions have a different name. The one that I just wrote up here is called cosine. Okay? So here's what I want you guys to do. I want you guys to do, on your phones, I don't know, it's either 60 and then cosine or cosine and 60. So figure it out. See what your calculator does. Do cosine of 60. And what do you get? What? 0.5, right? And isn't that 1/2? All right, so your calculator knows the special right triangles. It knows, your calculator knows that if this angle is 60, then this side over this side has to make a 1/2. It knows that. Yeah, what's up?
The calculator got negative 0.1.
Negative. So the reason for that is probably because your calculator is set in radians. Do you see in the top corner somewhere it says rad?
Yeah.
Okay, so fix that. Change it to DEG instead of RAD. There's a button that you can.
Oh, I see.
Yeah. And then you'll get 0.5. Okay. So, okay, bonus point. I owe one already to Nora. What is the radians for 60 degrees? Give you 2 points if you could tell me. Radians for 60 degrees. It's on the unit circle. Nice. Najib gets 2 points. Pi over 3. So if you want to change your calculator back to radians and push cosine of pi over 3, guess what you get? 0.5. Okay. Now, so I owe you guys points. I haven't written them down yet, so ask me later. Make sure you check them out. Forget. But we only know the special right triangles, 60 and 45, because they have beautiful answers that just happen to work nice. But every triangle, no matter what the angles are, will always have a certain ratio. So for instance, just like on a 30, 60, 90 right triangle, the short leg to the hypotenuse will always be 1 to 2. Doesn't matter how big it is. If I told you this was 70, I don't know what the ratio of this, let's say this was 8. I don't know what this would be right now off the top of my head. But there's a ratio between those. And your calculator, unlike us, your calculator knows all of the ratios for any triangle. So for instance, push cosine of 70 and see what you get. What would you get? Oh.
Yeah, 0.34.
0.34? Okay, so what that means is that 8 over something has to equal 0.34. Now we could solve for x. I'm not going to right now. We're going to do that later on today. But the point is, whatever this side is, when I divide 8 by it, I should get 0.34. That's what that side would have to be on a triangle with a 70-degree angle there. Okay, so trigonometry is the relationship between the angles and the sides of a triangle. Okay, so let's go ahead and write down a definition now that we've got that. So what is a trigonometric ratio? It's a ratio of two sides of a right triangle. It's a fraction out of two sides of the right triangle. And the value of that fraction is determined by the angles of that triangle. Okay? Now there are, okay, another bonus point. If we have 3 numbers, how many different ways can you turn that into a fraction? This is just a fun permutation question. If you have 3 numbers, how many ways can you take 2 of them and just make a fraction? 9? No. Okay, so good. So here's the thing. Let me change my question, but I'll give you a point anyway, because you're right. How many ways can you make a fraction if you use only, you can't use the number with itself, like you couldn't do the short side over the short side, right? Or if I give you 3 numbers like 1, 2, 3, you couldn't do 1 over 1. That's not allowed. Okay, so how many different ways could you do that?
6.
Nice, you're good. All right, so it is 6. There are 6 of them. So let's write that. There are 6 trig ratios. Okay, there are 6 trig ratios. Their names are sine, cosine, tangent, cosecant, secant, and cotangent. These are the abbreviations for those words. But there are 6 different ways you can make a fraction out of 3 numbers, right? So if you take the 3 sides of a triangle and make all the different possible fractions that you possibly can, each one of those has a name, and it's one of those. Yes.
What is the last one?
COT.
Meaning what?
It stands for cotangent.
Isn't that the opposite of tangent?
Yeah, and the way that I wrote it up there was on purpose. Like cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, but we'll get to that later. So for now, I just want you to know there's 6 different ways you can make a fraction out of 3 different numbers, and each of those has a name whenever you're talking about the sides of a right triangle. Now our calculators only have these buttons, right? Most calculators don't have the other 3, but we'll talk about how to deal with that a little bit later. All right, so before we tell you how you can tell which is which, we need to learn how to name the parts of a triangle. So, okay. So, when you have a right triangle, I'm always going to give you an angle of some kind. let's say it's this one. That angle's name is the reference angle. Okay, I could have picked this one up here, but I'm going to pick that one. Now, each of the sides are going to get a name. We already know the name of the longest one. What's the name of the longest one? That's the hypotenuse. Now, yesterday, or the lesson before this one, we were talking about long side, short side, but we're going to name them a little bit differently today. We're going to name them opposite and adjacent. Okay? Opposite means it's opposite from or across from the reference angle. So which side is opposite from my reference angle here? The one on the... This is opposite. Like directly across from it. So we're going to call this the opposite side. The other one, we'll just call it the other one. The other one is the adjacent side. Adjacent means next to. Don't you guys agree that it's next to the reference angle? It's like touching. It actually is part of the side of the adjacent angle, right? So it's next to it. But so is the hypotenuse. But we don't call that adjacent because it's a special side. It's the hypotenuse. So we have the hypotenuse, the opposite, and the adjacent side. Now I'm going to draw the same triangle, but this time I'm going to change my reference angle. I'm going to put my reference angle up here now. If I put my reference angle up there, does that change my hypotenuse?
No.
No, that's still a hypotenuse. But now which side is the opposite side? Which one is across from the reference angle? The one on well, that is a smaller one. The one on the bottom though, right? So now this is my opposite side. And what's this one? That would be the adjacent. You guys have seen this in geometry, have you not? Okay, this should be review for the most part. So how you name the sides depends on which reference angle you're talking about, okay? So if this is my reference angle, that's my opposite, that's my adjacent. But if I make the top my reference angle, now this is my opposite and this is my adjacent. Okay? So it's very important. We're going to be building up some knowledge here today, and this is the first foundational piece. It's very important you're able to name these, because if you can't, then you can't do the next part. So we got to make sure you're good at naming these. So let's do a little drill and kill. You don't have to write this. You can, but it's not necessary. I'm going to draw some triangles up here. I'm going to label the sides A, B, and C, and I'm going to call that my reference angle. Okay? So I'm going to ask you which one's the opposite side. I'm going to give you 3 seconds to think about it, and then I'm going to call on you to tell me which one's the opposite side. Don't shout it out, though. I want people to get a chance to think. That's much longer than 3 seconds, but I had to get my cards out. All right, so Armando, what's the opposite side? Good. Next question. Which one is the adjacent side? 3 seconds. Brooklyn, what do you think? C is correct. All right, new picture. That's my reference angle now. We'll call this A, B, and C. So which one is the hypotenuse? Melanie, what do you think? C. C is correct. Next question. What is A? Think about it for a moment. Juliana, what do you think? Opposite. Very good. All right. Do we need more practice? We're good? Okay, so that's important you guys are able to identify opposite, adjacent, and hypotenuse. Okay, so that being said, let's go ahead and actually define these trig ratios now more specifically. Okay, here we go. Sine. Now, first of all, whenever you do a trig ratio, you always have to tell your trig ratio which angle is your reference angle, because doesn't that change which one's opposite and adjacent, right? So you can't just put sine, you have to put sine of a specific angle, okay? Because that angle tells you which one is your opposite and which one's your hypotenuse and which one's your adjacent. So if you don't have an angle there, then sine becomes meaningless. So this is my reference angle in this case. Now, sine is always, does anybody remember?
Yeah,
Very good, SOHCAHTOA, right? Sine is opposite over hypotenuse. So, remember SOHCAHTOA from geometry?
Oh my gosh, I remember that.
Yeah. I'll write it down for you in a minute, but for now, let's just get the definitions up here, but then I'll show you how you can remember these. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Yes. So H is hypotenuse, A is adjacent, O is opposite. So sine is, well, I'm not going to say it again, it's up there, but you guys got it. Now, those are 3 of the possible fractions that you could make out of the sides of a right triangle. But we said there were 6. The other 3 are the reciprocals of these. So if you just flip them over, and those have names too. So the reciprocal of sine is known as cosecant. Cosecant of theta is h over o. Now this one you probably did not learn in geometry. They don't really get into the other 3. Now you might have had a really cool teacher that did it, but usually they don't get into them. Cosine. The reciprocal of cosine is called secant. So secant of theta is hypotenuse over adjacent. And then the reciprocal of tangent is cotangent, which is adjacent over opposite. So those are your 3 trigonometric ratios.
So do I have to memorize these?
Yes. And so to help you with that, on this side, we have something that could help you, and it's what Cleopatra shared out with us. It's SOHCAHTOA. No, SOHCAHTOA. Not O, SOHCAHTOA. All right, just kidding. Okay, so sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, it's kind of easy to remember that cotangent goes with tangent, right? They're kind of named the same. Unfortunately, these ones are a little bit confusing. It would have been so much cooler, in my opinion. There's probably some language reason that I'm unaware of. But I wish they would have made secant the reciprocal of sine and cosecant the reciprocal of cosine. That way I could say the s's go together and the c's go together. But they don't. It's flipped. So, sorry.
That's what makes things hard. They just do stupid things.
Well, not everybody speaks English. I'm sure there's a reason for this that we don't know. All right. Let's go ahead and get to work here. Let's actually do some math now. So what is a trig ratio? It's a fraction of the sides. How many ratios are possible? There's 6, and each of them have a name, and here they are. Why do we care about these? Because the sides of a triangle and their ratios are based on the angles. And we can answer questions like I gave you earlier. Remember the one with the 70 and the number and the missing side? Well, now, since we know that they have that relationship, we can solve that missing side. So that's why we care about trigonometric ratios. So let's go ahead and do an example here. We'll start with something easy. Here we go. Sine, let's go ahead and put theta here. Now theta, that's my way of identifying my reference angle. So sine of theta All right, so let's go through this a little bit. Sine is what over what? Opposite over hypotenuse. So what's my opposite? 4. What's my hypotenuse? So it's 4 over 5. So sine of this angle, whatever it is 4/5. I don't know what that angle would be, but if you had a triangle that was 3, 4, 5, this angle would have to be a certain number. And that number would be a number that you could put in your calculator and push sine of that number, and it should give you 0.8, which is 4/5. All right, let's do another one here. What if let's go ahead and call this one B. What about tangent of B? I'm going to change my reference angle here. I'm going to change my reference angle. So think about that one for a moment. My first question to you is, tangent is what over what? Opposite over adjacent, right? I'll put that over here on the side. But now since B is my reference angle, what's the opposite?
3.
And what's my adjacent? There you go, 3/4. So you have to look at your reference angle, you have to name your sides, and then you can make your ratio. Let's do another one. Let's try cosecant of theta. I'm back to theta now, right? So I'm going to use my cards this time. I'm going to ask Alondra, cosecant is what over what? Well, that's the answer. Maybe you're right. But what I mean right now is just opposite, adjacent, and stuff. So what is cos?
It's adjacent over.
No. It's hypotenuse over adjacent. There we go. No, wait.
No, it's
All right. All right. Hypotenuse over adjacent, opposite. Man, that adjacent really wants to make its way in there for some reason. All right. So, Julissa, what is my hypotenuse?
5,
What's my opposite? I wanted to say adjacent again. What's after this?
4.
4. Yes. Because 4 is opposite from the theta, right? Okay. Let's do another one. Last one on this slide. How about, let's do cotangent of beta, or not beta. They do name them that sometimes, but we'll say B for now. Cotangent of B. So PJ, cotangent is what over what?
Adjacent over opposite.
Adjacent over opposite. All right. So Nora, we're doing B now, right? That's my reference angle. So what's adjacent over opposite? 4 over 3 is good. Nice. Okay. So that's the basic idea. Let's take it up a notch.
Just one notch, right?
All right. I guess we can call this example 2. Why not? I feel like I should test what you. I feel like you guys know this, but I also feel like we should stop and make sure you know it. But I don't know. We'll go forward. We'll see what happens. All right. Square root of 19. Square root of 3.
Why?
This is 5 notches.
All right. Here's what we're gonna do. Well, I'm gonna do this one with you. Let's do. I haven't done secant yet, so let's do secant of A. Secant of A. Now you guys know how to do the trig, and you also know how to do the other thing, but I'm just asking you to do 2 things now, so it might seem a little overwhelming. But you actually know how to do all this based on my observations in the past 2 days. So here's my first question to you, Edwards. Secant is what over what?
Secant is hypotenuse over adjacent.
I agree. Hypotenuse over adjacent. So, Amanda, if secant is hypotenuse over adjacent, and my reference angle is what?
19 over
Good. So if my reference angle is A, then my hypotenuse is 19, square root of 19. My adjacent is a square root of 3. Okay, now here's why these ones are a little bit more of a pain in the butt. That's right. Tavier, what do we have to do here that we didn't have to do last time? Huh? This guy. Last time we could just stop and be done here, but now we have to deal with something. What's that? We don't like square roots on the bottom is what it is, right? So how do we get rid of square roots on the bottom?
Multiply top and bottom by square root.
That's right. You multiply the top and the bottom by the square root of 3. So the bottom's just going to become 3 now, and the top's going to be 30 plus 27 is 57, and that's not going to reduce, so we can just leave it like that. Okay? So just remember, you can't have square roots on the bottom. All right, let's do another one. How about, I think we've done almost all of them. Let's do cotangent of B. I'm going to let you guys go ahead and try that one from beginning to end on your own and see how you do. I'll pause, give you about a minute. First question is going to go to Cleopatra. Cotangent is what over what? Good. Adjacent over opposite. Connor, what is the adjacent side in this case? Good. And what is the opposite? Good. So if B is my reference angle, that's the opposite, and 4 is the adjacent, right? All right, next we have Tammy. I need to multiply the top and the bottom by the square root of 3, and if I do that, what do I get as my final answer?
Wait, no. Radical 4 over.
Bless your
4
heart.
radical 3.
Yeah, there you go. Over 3. You can't actually multiply those numbers, right? Because the 4 is not a square root, so you just put them next to each other. All right, so there you go. It seems to me like you guys have got that down pretty decently. So the trick there is remembering your trig ratios. SOHCAHTOA is really nice, but you're going to have to do something about the secant, cosecant, and cotangent, right? All right. So I feel like we're going quick, but you guys are doing well. Well, for you it is.
We should do some stupid practice.
I'm going to move forward.
No.
No, we can take a little.
No.
I think
For the other.
no, everybody in this class is doing pretty decently from what I have observed.
Actually, I'm kind of.
Yeah, well, you had the answer on your paper. Okay. All right. Well, let's see. Let's push you guys to the limit here and see what you can do. Let's do example 3 here. So let's go back to that 70 question that we had earlier today. Was this 8? I think it was. So if I've got a triangle with a 70-degree angle there, then that bottom side has to have a certain ratio with that hypotenuse, okay? Now, can somebody explain to me, I've got to start writing these down because I still have, let me pause the video. I owe a lot of points. So why can't we use Pythagorean's theorem?
Because there's another leg.
There's not another leg. When you're using Pythagoras theorem, you need at least 2 sides. All right, my next question. We also found missing sides of a right triangle in other ways yesterday, like with the 30, 60, 90s or 45, 45, 90s. Why can I not do that here? It's not one of those special right triangles, right? It's a 70-degree angle. We don't have any little rule for that one. Good news is our calculator knows all the triangles. We only know those special ones, but our calculator knows all of them. So our calculator is going to help us. Now I'm going to give you guys some steps on how to do this. Once again, you probably should have done this in geometry, but this process was always difficult for geometry students. You guys have grown up a little bit since then, so you'll probably find it a little bit easier. But there's still a lot of steps involved, and so I'll give you some written steps as we go to kind of keep in mind. So the first thing you want to do is you want to identify your reference angle. Yeah. So what's my reference angle? 70, right? So check. We know that. Step 2. You might want to label your sides. So if 70 is my reference angle, what am I going to call this side over here? What am I going to call this?
Adjacent.
And what am I going to call this? Okay. And all these steps are really just kind of like baby steps. You don't. Eventually, maybe you'll get to a point where you don't need to do these. You know, some of you may not even need to do them already, but they're just to help us because there's a lot of cognitive work that has to happen here to make this work. All right, so identify what you want and what you have. So identify what you want and what you have. What do I want? I want my hypotenuse, right? What do I have? I've got my adjacent. Okay, now the reason we need to do that is because the side that I want and the side that I have, I'm going to use those 2 sides to get the missing answer. Okay? So since I'm using those 2 sides, that tells, this is the big question. The next thing we have to do is we're going to make an equation. And that equation is going to have sine, cosine, or tangent in it. One of those 3, not the other 3. Don't worry about y for now. But it's going to be sine, cosine, or tangent. And the big question I get is, how do you know which one it is? Well, the answer is, it's based on what you want and which one you have. I wrote adjacent here twice. I meant to put have here. All right. So I don't want you guys to shout it out, but I want you to quietly just look at your notes, and I want you to think for a minute. I have a hypotenuse and an adjacent. Which trig ratio, don't shout it out, which trig ratio has a hypotenuse and an adjacent? Now there's 2 answers to that question. I want either sine, cosine, or tangent though. Okay, so I'm going to write some notes so you guys think about that while I'm doing this. Okay, now on the count of 3, which one?
Cosine.
Cosine, thank you. So it's cosine. That's the big question I was getting. How do you know which one it is? It's because it's the one you want and the one you have. Which trig ratio has that? So in this particular problem, I'm using this one. I'm not going to use sine. I'm not going to use tangent. I'm going to use cosine. And I'm going to write an equation using this little setup right here. Okay, so let's go ahead and write our equation out. Cosine of theta. Now theta is my angle. What is my angle? 70. And cosine is adjacent over hypotenuse. So what is my adjacent? 8. And my hypotenuse? We have an equation. And we can solve that now. So cosine of 70 should have a certain ratio for 8 and x, right? So let's go ahead and solve it. So on your calculators, let's do some math first. let's do some math first. Let's go ahead and I want to get x by itself. So the first thing that I'm going to do to get x by itself is I'm going to multiply both sides by x. So I can get it off the bottom, right? Now what do I do to get x by itself? You're going to divide the cosine, right? So now that's not a pretty thing to look at. We're going to actually use our calculators to turn this into an answer now. So on your guys' calculators, I want you guys to push 8 divided by cosine of 70 and see what you get. So if we punch that into our calculator, we should be getting 23.390-ish. So let's not miss the gravity of what we've just accomplished here. I told you I have a triangle with an angle of 70, and I told you this side here was 8. We just used trigonometric ratios to prove that this side has to be 23.39. That's what trigonometry does for you. It allows you to use an angle to find the relationships between the sides. Okay? So that's what trigonometry is. So let's do another example. This time I'm going to let you guys walk me through the steps a little bit, and then I'll set you loose on a student practice. So here we go. Let's say that this is 10, and this is x, and this is 40 degrees. All right, go ahead and write that down. This is a guided practice. All right, so Ava, what's the first thing that I said we need to do first?
Label the type.
That was second.
Find reference angle.
Yeah, you got to know your reference angle before you label your sides, because that tells you how to label them. So, Najib, our second step is to label the sides, right? So what are they? What's this one?
The opposite.
Opposite. What's this one?
Hypotenuse.
Hypotenuse.
Adjacent.
Adjacent. Okay, now third step. Let's, Cameron, third step.
Find which one you need.
Identify which one you need. So which one do I need?
The adjacent.
Well, yeah, we don't know that either, right? But we want the opposite. So we're looking for the opposite. And what else do I identify, Cameron? Identify what you want, and identify what we have. And what do I have? Good. All right, now I'm gonna let you guys think for a minute. Which trig ratios am I going to use? Sine, cosine, or tangent? Don't shout it out. Am I going to use sine, cosine, or tangent? What do you think, Sid? So it's not tangent. Now I'm gonna give you some information. I'm gonna give you a second to try again, okay? The one I'm looking for has to have the one I want and the one I have. So it's got to have opposite and hypotenuse. So which one is that? You got it. All right. So the next thing I'm gonna do is I'm gonna let you guys write your equation. Just write the equation. I'll give you a second to write the equation and see what you get. Not asking you to solve it yet. Just asking you to write it. Okay, so I'm going to ask Leilani, what did you get for your equation?
10, 40 equals x over 2.
Good. Okay, now we get to solve it. All right. So Ezekiel, if I want to solve for x, what would you do first? Good. And how would you do that? Multiply both sides by 10. This one's going to be a little bit less work to solve because now I've got x by itself already, right? On the last one I had to divide also, but here we're good. So now we just get to type this into our calculator, 10 times sine 40. So go ahead and do that and see what you guys get. Should be getting 6.428. Okay. So now, I didn't tell you why we're not using the other 3 trig ratios. Remember, you know how when we're writing our equations, it's going to be sine, cosine, or tangent? Does anybody know why I'm not using the other 3? So it narrows our options down, but there's another reason. That's kind of it. Do you guys see a secant, cosecant, cotangent on here? We can't do that. So it's got to be sine, cosine, tangent for that reason there. So that's the reason why we're only using those 3. Yeah.
How do you put that into the calculator?
So on your phone,
Yeah.
do 10 times 40 sine equals.
Oh, I see. Okay.
But it's different on here, right? So on here, you can type it exactly the way it looks. On your phones, got to do a little bit different. All right, so before we go, I want to give you guys just one to do completely on your own from beginning to end. All right, let's say that this is 5, and this is x, and this is 20. Go for it.